Hello friends, this is Rashmi Singh. Welcome to my channel Unraveling Science. Solutions for human eye and the colorful world around us. Class 10, Chapter 10. Questions in the chapter. First, what is meant by the power of accommodation of eye? The ability of the eyes to adjust its focal length to see the nearby and the distant object clearly is known as the power of accommodation of the eye. Second, a person with a myopic eye cannot see objects beyond 1.2 meters distinctly. What should be the type of corrective lens used to restore proper vision? A person with myopic eye should use a concave lens of focal length 1.2 meters so as to restore proper vision. What is the far point and the near point of a human eye with normal vision? The near point of the eye is the minimum distance of the object from the eye which can be seen distinctly without strain. For normal human eye, the distance is 25 centimeters, and the far point of the eye is the maximum distance to which the eye can see the objects clearly. The far point of the human eye is infinity. A student has difficulty reading the blackboard while sitting in the last row. What could be the defect the child is suffering from? How can it be corrected? The student is suffering from myopia or short-sightedness. The defect can be corrected by use of concave or diverging lens of appropriate power. Back exercises. The human eye can focus object at different distances by adjusting its focal length of eye lens. This is due to A. Presbyopia, B. Accommodation, C. Nearsightedness, and D. Farsightedness. The correct option is B. Accommodation. Second, the human eye forms image of an object at its A. cornea, B. iris, C. pupil, or D. retina. The correct answer is D. retina. Third, the least distance of the distinctive vision for the young adult with normal vision is about A. 25 meters, B. 2.5 centimeters, C. 25 centimeters, or D. 2.5 meters. The correct answer is C. 25 centimeters. Fourth, the change in focal length of an eye lens is caused by the action of the A. pupil, B. retina, C. ciliary muscles, or D. iris. The correct answer is C. ciliary muscles. A person needs a lens of power minus 5.5 dioptry for correcting his distant vision. For correcting his near vision, he needs a lens of plus 1.5 diopter. What is the focal length of the lens required for correcting a distance vision and a near vision? The power P of the lens of focal length f is given by the relation P is equals to 1 by f. So the power of the lens used for correcting the distant vision is minus 5.5 d. So the focal length of the required lens will be f is equals to 1 upon p. Putting the values of p here, we get focal length minus 0.181 meters. So the focal length of the lens for correcting distant vision is minus 0.181 meters. Now the power of the lens used for correcting near vision, which is plus 1.5 d. So focal length of the required lens will be f is equals to 1 by p. Putting the values, we get focal length 0.667 meters. So the focal length of the lens for correcting near vision is 0.667 meters. Sixth, the far point of the myopic person is 80 centimeter in front of the eye. What is the nature and power of the lens required to correct the problem? The person is suffering from an eye defect called myopia. In this defect, the image formed in front of the retina. Hence, a concave lens is used to correct this defect of vision. Object distance u here is infinity. Image distance V is minus 80 centimeters. Focal length is f. So according to the lens's formula, 1 by v minus 1 by u is equals to 1 by f. Putting the values, we get focal length minus 80 centimeters or minus 0.8 meters. Now we know that power is equals to 1 upon focal length. So putting the value of focal length here, we get power minus 1.25 diopters. 7th, make a diagram to show how hypermetropia is corrected. The near point of hypermetropic eye is 1 meter. What is the power of the lens required to correct this defect? Assume that the near point of the normal eye is 25 centimeters. A person suffering from hypermetropia can see distant objects clearly but faces difficulty in seeing the nearby objects clearly. It happens because the eye lens focuses the incoming divergent ray beyond the retina, as you can see here in the picture. This defect of vision is corrected by using convex lens. A convex lens of suitable power converges the incoming light in such a way that the image is formed on the retina, as shown here in this picture. Near point of the defective eye is 1 centimeter or 100 centimeter, and that of the normal eye is 25 centimeters. So here object distance is minus 25 centimeters and image distance is minus 100 centimeter. Using the lens formula and putting the values of here, we get the focal length 33.3 centimeters or 0.33 meters. Now we know that power is equals to 1 by focal length. So putting the value of focal length here, we get power is equals to plus 3 diopters. A convex lens of power plus 3 diopter is required to correct this defect. 8th, why is the normal eye not able to see clearly the objects placed closer than 25 centimeters? At a distance less than 25 centimeters, the ciliary muscles cannot budge the eye lens anymore. The object cannot be focused on retina and it appears blurred to the eye. 9th, what happens to the image distance in the eye when we increase the distance of the object from the eye? The image is formed on the retina even on increasing the distance of the object from the eye. In fact, the eye lens becomes thinner and its focal length increases as the object is moved away from the eye, and consequently image is formed on the retina. 10th, why do stars twinkle? Stars appear to twinkle due to atmospheric refraction. The starlight on entering the Earth's atmosphere undergoes refraction continuously till it reaches the surface of the Earth. Stars are far away, so they are the point sources of light. As the path of the light coming from the stars keep changing, thus the apparent position of the stars keep on changing, and the amount of light from the star entering the eye keep twinkling, due to which star sometimes appears bright and sometimes dim, which is the effect of twinkling. 11th, explain why planets do not twinkle. The planets are much nearer to Earth than stars. Because of this, they can be considered as large sources of light. If a planet is considered to be the collection of very large number of point sources of light, then the average value of change in the amount of light entering the eye from all point-sized light sources is 0. Due to this, effect of twinkling is nullified. Why does the sun appear reddish early in the morning? During sunrise, the light rays coming from the sun has to travel a greater distance in the Earth's atmosphere before reaching our eyes. In this journey, the shorter wavelength of light are scattered out and only a long wavelength are able to reach our eyes. Since blue color has shorter wavelength and red color has longer wavelength, so the red color is able to reach our eyes after atmospheric scattering of light. Therefore, sun appears reddish early in the morning. Why does sky appears dark instead of blue to an astronaut? Sky appears dark instead of blue to an astronaut because there is no atmosphere in the outer space that can scatter the sunlight. As the sunlight is not scattered, no scattering light reaches the eye of an astronaut and sky appears black to them. Thanks for watching. Please do like, share and subscribe.